morning to all. Today we are going to discuss some more questions related to continuity. Yesterday what we have started continuity in an interval at a point. Today after some questions we will go to what is how to discuss continuity in an interval, that also I am going to discuss. So yesterday what we have done, continuity at a point means left hand limit, right hand limit at the point, all three must be equal. If one of them differs from others, discontinuous. So okay, let us start. The question is, if the function is continuous at x is equals to 4, find the values of a and b. If the function is continuous at x is equals to 4, the point is given, what is that, x equals to 4, find the values of a and b. As it is continuous, you can see that there is LHS, so left hand limit, LHS, limit x tends to 4 minus fx. Wherever x is there, I will replace it by 4 minus h. Limit x tends to 0. 4 minus h minus 4 modulus by 4 minus h minus 4 plus k. 4 cancelled out, 4 cancelled out. Usually we can see that minus h modulus is plus h, this is minus h. This is h by minus h plus k. Limit s tends to 0, that is equals to a minus 1. So left hand limit I got a minus 1. This gives you minus 1, a minus 1. RHS limit x tends to 4 plus fx. Again replace the 4 plus h here. This is modulus, okay. Limit x tends to 0. 4 plus h minus 2. 4 plus h minus 2 plus p. 4 cancelled out. Cancels out. This is h plus h by h, that is just limit x tends to 0. H by h plus b, this gives you 1, b plus 1. And you can see that at the point the value is a plus b. As it is continuous, LHS is equals to RHS is equals to limit x tends to 4 fx. That means we got the condition a minus 1, b plus 1, a plus b. At the point it is given you as a plus b. So compare a minus 1 with a plus b. Compare a minus 1 with a plus b. A cancels out, b is equals to minus 1. Compare b plus 1 with a plus b. B cancels out, so a is equals to 1. Hence we got the answer, a is equal to 1 and b is equals to minus 1. But the question was given, if it is continuous at x equals to 4, find the values of a and b. So there is left hand limit, the point is 4. LHL I got 4 minus h, 4 minus h. HH I cannot cancel, it means it will be cancelled out. Minus 1 is left, a minus 1. RHL I got b plus 1, and at the point is equals to a plus b. Equal to a minus 1 is equal to a plus b, a cancelled out, b is equal to minus 1. B plus 1 is equal to a plus b, b cancels out, so a is equal to 1. That's the answer. Right on. given. The given function is continuous at x equals to 0. We are discussing continuity at a point. The continuous at x equal to 0. The function is divided into three parts. X is less than 0. This condition is given. X is equal to 0. 3 by 2 is given. X is greater than 0. This value is given. If it is continuous at x equals to 0, find the values of a, b. Something I am missing out. Just 1 minute, give me. Let's check the question. At x equal to 0, this is c. Okay, let's start. LHS. Limit x tends to 0 minus fx. As it is continuous, we write down the first step. LHS is equals to RHS is equals to limit x tends to 0 fx. That condition write down. Limit x to 0 minus. So what I do? Limit x tends to 0. Wherever this is less than 0, instead of x, I will replace 0 minus h. This is argument of sign. You cannot separate it. Sign of 0 minus h by 0 minus h. That gives you now limit x tends to 0. Sign. Multiply this. Bring minus outside. A plus 2 into h minus sin h by minus h. Yesterday what I told you, limit x tends to 0, sin x y is equals to 1. If it is sin 5x, denominator also has to be 5x and 5x tends to 0. So I will adjust here. Limit x tends to 0, sin a plus 2h minus cancels out. H is there, so adjust it here. Multiply and divide by a plus 2. And this is argument is getting 0 plus sin h by h. You can see that now this becomes 1. A plus 2 sin h by h, that gives you 1. A plus 2, this becomes 1. What I am writing in yellow color, this becomes 1. Alright, so this becomes 1. That gives you now a, this is a plus 2, this is 1, a plus 3. So LHL I got a plus 3. Alright, at the point limit x tends to 0 fx, at the point it is c. At the point it is equals to c. So c is equals to a plus 3. Then I will go to RHL. Limit x tends to 0 plus fx. I will replace here. Limit x tends to 0, 0 plus h plus b h square. Because I replaced with 0 plus h, so 0 is left out. H b h square root under minus root h by again 0 plus h b s to the power b by u. Whenever a particular either a term in numerator or denominator, if it is 0 by 0 form, it is under the format root a minus root b or root a plus root b. Rationalize it. So rationalize this particular part. Limit s tends to 0. Rationalize in the positive term. Rationalize it. Multiply a minus b, a plus b, a square minus b square, limit h tends to 0. That gives you h plus bh square. A square, its square minus its square minus h. You take h common from here. As it is under root, when I take h common, it becomes root h. It comes root h. That root h is to the power 1 by 2 multiplied here. H to the power 3 by 2 into h to the power 1 by 2. Again I am telling I will take h common from here. Once I take h common from here, that h to the power 1 by 2 added here with the power, that becomes h square. And divide it here h inside. That gives you 1 plus bh plus 1. H by h cancels out. Now h is cancels out. Left over limit h tends to 0. bh square by bh square 1 plus bh plus 1. This whole gets cancelled out and h tends to 0. This is bh. H tends to 0. 1 plus 1, that is 2. This keeps you 1. This is 0. 1 plus 1, 2. This becomes 1 by 1. That is 1 by 2. That means RHL gives me 1 by 2. LHL a plus 3. At the point C, LHL a plus 3. LHL a plus 3. At the point C, RHL 1 by 2. So I got the value here. C is equals to 1 by 2. C is equals to 1 by 2. A is equals to 1 by 2 minus 3. A is equals to minus 5 by 2. A is equals to minus 5 by 2. And there is, I am not getting the parameter B here. Then what will be the value of B? There is no scope of getting B. So as if look at the question, B is in the denominator. That means B can take all the real values other than 0. So B will be, B belongs to R minus 0. Alright, that means I got the answers here. This question, this is LHL, this is RHL. LHL I solved here. I got A plus 3. RHL I solved 1 by 2, and at the point it is given as C. Alright. Now, other question I get fx is equals to e to the power 1 by x minus 1 by e to the power 1 by x plus 1. X is not equal to 0 and 0 when x is equals to 0. Check the continuity. Check the continuity. Alright? But about exponential series, what you know? E to the power 0 is equals to 1. E to the power x, x belongs to R domain. Alright? E to the power infinity is not defined. Means e to the power infinity tends to infinity. Suppose if I am getting e to the power 1 by h and h tends to 0. So what it gives me? E to the power 1 by 0, e to the power infinity, that means infinity. So whenever I get e to the power 1 by h format, I try to convert it in the form of, I am telling you, e to the power 1 by h. I try to get it in the form of, it tends to infinity. And if I convert it, it will be 1 by infinity, that becomes 0. So my logic is now, whenever I get e to the power infinity in the numerator, in that format, I divide it by e to the power infinity. So how to do it? Not equal to 0, LHL, let's go first. Now, what I told you, now you think, if I replace h tends to 0 here, is e to the power minus infinity. So bring a denominator in the form denominator. So limit s tends to 0, 1 by e to the power 1 by h minus 1, 1 by e to the power 1 by h plus 1. Don't take LCM. I am writing here. E to the power 1 by h s tends to 0 is equals to e to the power 1 by h tends to infinity. So 1 by e to the power 1 by h tends to 1 by infinity tends to 0. So now you can see that this becomes 0, this becomes 0. It is minus 1 by 1, that gives you minus 1. Fine? RHS. Limit x tends to 0 plus fx. Limit x tends to 0, 0 plus, here only I will substitute value, 0 plus h. Now it will be, if I replace s tends to 0, this gives me infinity. What I told, when I get infinity, I will divide by e to the power 1 by h. Divide by e to the power 1 by h. That gives you now limit s tends to 0. 1 minus 1 by e to the power 1 by h. Here also 1 plus 1 by e to the power 1 by h. Now already I have written that value here, 0, 1 by 1, 1 minus 0 by 1 plus 0, answer is 1. LHL, RHL, both different, this is also different. LHL not equals to RHL, not equal to limit x tends to 0 x, this and this. Alright? You see, first LHL, x tends to 0 minus h. I got it in the denominator. This becomes 0, this becomes 0, minus 1 by 1. RHL, e to the power 1 by h. Divide the numerator denominator by e to the power 1 by h. Now this becomes 0, this becomes 0. 1 by 1, 1. Unequal values, discontinuous. Okay. If the function is continuous at x is equals to 0, find the value of a. If the function is continuous at x is equals to 0, find the value of. Sometimes the questions also becomes difficult to understand, because if I go for LHL and I equate it to a, because there is no parameters there, definitely I will get a value here. If I equate it to a, I will get the value of a directly, then why to go for RHL? Sometimes the question makes me confused. Creates the confusion about that. Might be given that the function is continuous, but once you start checking it, it may not be continuous. So I'll go for LHL, RHL equated to at the point. All three should be that this should be equal, this should, and the value will be a, then only I get. So the first start with LHL. Limit x tends to 0 minus. Limit x tends to 0. 0 minus, if I start with here, 1 minus cos 4, 0 minus h. 0 minus h minus h whole square. That gives you limit x tends to 0. Cos of minus theta cos theta, 1 minus cos 4h by h square. Limit x tends to 0. 2 sin square 2h. 2 sin square 2h. Yesterday I told you the formula, limit x tends to 0. If it is sin cube 2x, I need 2x whole cube, remember. then it becomes 0, 1. X tends to 0. If I replace 0 by 0 form, sin cube 2x, I get the parameter whole cube here. If it is 4, I need 4 here. Right? So that's the way we have to take. Now if I look at the solution here, it is 2 sin square 2h, denominator h square is there. So sin square 2h, I need 2h whole square here. That means 4 is missing. So divide by 4, multiply by 4. Limit is tends to 0. 2 sin square 2h, 4h square into 4. This becomes 1. 8. I could have written a is equals to 8, but I want to check this one as well. That must gives me 8 as well. If I look directly substitute, I will get 16 root under this is x tends to 0. 4 minus 4 0. So what I do now, RHL. Limit x tends to 0 plus 0 plus h. Plus root h minus 4. Rationalize it. Because if I replace x tends to 0 here, this is in 0 by 0 form. Rationalize the denominator. That gives you 16 plus root h minus 16. When these value multiplied this one, a square minus b square. Its square root on 4 square 16. 16 cancels out. Next step root h cancels out. Now replace x tends to 0. Once the denominator will go on, so this is 4 plus 4, 16 root under this 0, 16 root under 4, 4 plus 4, 8. Now all these two are equal, RHL equals to this value. So answer is A is equals to 2. Alright? Now, what is continuity in an interval? We are almost whatever questions are solved, that is a continuity at a point. If a function fx is continuous in interval open interval A to B open, then it must be continuous all the points in between A to B. That means in between A to B, whatever points comes, open interval, so I cannot take A and B. Whatever points comes in between A and B, at each point it must be continuous. There should not be any point of discontinuity. That means if a curve, I am thinking about a curve, this point is A, this point is B, that means in between this to this, wherever point, whatever point you consider, the function should be continuous. Then only it is continuous in the open interval A to B. Then comes use if a function fx is continuous in closed interval A to B, closed interval, then let it change. Then including A and B, and all the points between A and B, it must be continuous. That means in this case A and B is also included. The 2 points, the endpoints, because closed interval. So including A and B and all points in between A and B is continuous. So we will go with the question from this side. This particular continuity interval. Okay. That means if the function is indirectly it is given that the function is continuous in the interval 0 to 10. Or I can take closed interval also. If I take closed, it will become closed. The function is continuous in between 0 to 10. We can go for open, closed, semi-open, semi-closed, no problem. If it is closed, means continuous 0 to 10. Then in between these 2 points, including these 2, 0 to 10, whatever points you consider real value, the function must be continuous. But I have to find out what is given in the question, what point is given and which has got 3 conditions. So if I look at the question, x is less than 2, greater than equal to 2. That means it is individually continuous at 2, a condition 4. That means we will check the continuity at 2 points. Continuity at x equals to 2. LHL is the alone conditions. I will go for it. It is given that the function is continuous at in between this, find a and b. It is given continuous. So LHL I have to consider. LHL I am considering limit s tends to 0. LHL limit x tends to 2 minus fx, limit s tends to 0, 2 minus h whole square, a into 2 minus h plus b. As denominator is not having h, directly replace s tends to 0, 4 plus 2a plus b. LHL I got. RHL 2 conditions there, greater than equals to. Whichever is easy you consider, obviously equal sign will be easy. At the point, limit x tends to 2 fx 3 into 2 plus 2, that is your 6 plus 2 8. So as it is continuous at x equal to 2, so LHL RHL limit x tends to 2 fx are equal. That means at this point is 2 minus, this is 2 plus. So for 2 this condition is equal. Okay, so I have calculated LHL. So first condition I got 2a plus b plus 4 is equals to 8. 2a plus b is equal to 4, equation number 1. That I got. Then I go with the condition 4. 4 is LHL here and here is another 2 conditions. Checking out. Right? LHL. Again LHL is single condition. So limit s tends to 4 minus fx. Replace here. Limit s tends to 0. 3 into 4 minus h plus 2. S tends to 0. 14. Go to RHL. Again RHL. Either you can go for RHL or you can go for, suppose if I go for RHL also, or at the point I can go. Limit x tends to 4 plus. It is given continuous. So 3 values LHL, RHL at the point, and this were overlapping. So I can go with anyone. If I would have gone with x equal to 4, would have been easy. But still then 4 plus, not that much lengthy. Fx is equals to limit s tends to 0. Replace here 2a into 4 plus h plus 3b. S tends to 0. Directly replace 8a plus 3b. So I got a condition. These two are equal. So 8a plus 3b is equal to 14. Equation number 2. First equation 2a plus b is equals to 4. Multiply 4 here. Multiply 4. 8a plus 4b equals to 16. Subtract it. b is equals to 2. b is equal to 2, a is equals to 1. b is equals to 2, a is equals to 1. We got the answers. Okay? This is a question about an interval. One more question will solve. Then we wind up this topic. If the function is continuous at x is equals to 0, find the value of a. This is a good question because very silly mistake is done by the students in this particular question. Okay, LHL at the point, I can go with LHL or I can directly go with at the point. So limit x tends to 0 fx. As it is given continuous, so LHL, RHL, limit x tends to 0 fx. So why I am going for LHL? 0 minus, as I got the chance to solve it with at the point, so I take at the point. So limit directly substitute x tends to 0 here, that gives me a sine pi by 2 into 0 plus 1. So sine 90 is 1, I got a. I got the value L at the point a, at the point. RHL, limit x tends to 0 plus fx. 0 plus h, 0 plus h, 0 plus h. That gives you limit x tends to 0. Tan h minus sin h by h cube. Tan h minus sin h by h cube. Limit x tends to 0. Tan h can be written as sin h by cos h minus sin h by h cube. Limit x tends to 0, take sin h common. 1 by cos h minus 1 by h cube. Limit x tends to 0, take LCM and divide this cos h here, tan h. Two steps are omitted here, one step omitted here. Sin h by cos h, I took the LCM into 1 minus cos h. Apply the formula here. Limit x tends to 0 tan h 2 sin square h by 2. Just now for some time I told you accordingly h cube is there, adjust here. H I need here. Then left over is h square. But as it is equal to h by 2, I need h square by 4. By 4 into 4. Alright, what I did again I am telling. H cube 1 minus cos h 2 sin square h by 2. I gave tan h by h, that becomes 1. I give it h here, I give it h square here. But h square will not work because sin square h by 2. So h by 2 whole square by 4 into 4. This becomes 1. This becomes 1. This is 2 by 4, 1 by 2. So I got at the point A, so A equals to 1 by 2. Right off. Okay, try to solve questions. Maybe you will find one or two difficult questions that I left for you. One is modulus function, you try to do it. Then some more questions are there. It will be not more, it will be 3 or 4 questions. It will be difficult, other than that. That is for you. Okay, thank you.